Okay, so previously on this channel, I made an entire video explaining how drones fly. But today with me, I've got an RC aircraft. This is a model and this is the fuselage. And what you're seeing right now over here is the wing span or the wing. This is the main wing that will be attached onto the fuselage. But the main purpose of making this video is to explain to you guys how RC aircrafts and real airplanes really fly. And that's why I spoke about the drone video in the beginning. So this aircraft is made out of a material called corrugated plastic, and corrugated plastic, also in short form known as Coroplast, is one of the most durable, also the most cost-effective materials that you can use to build an RC aircraft like this. This is a simple trainer aircraft, which means it's very simple to build, and it is the RC aircraft that people should start making if you as a beginner want to get started with RC airplanes. Now, the electronics and everything else is a different story, and I'll be making an entire video on that separately. But in today's video, as I mentioned, we'll be talking about how these aircrafts fly. Now, the principles that I'm going to be talking about regarding this aircraft applies to real aircraft as well, because as you know, RC aircrafts are basically scaled replicas of real airplanes, which we see in our daily lives. So the fuselage right here is small. I don't exactly remember the dimensions of this fuselage, but here's how it works. The corrugated plastic has been cut using knives. Some of the pieces are pre-cut using lasers, but most of them have been cut by me using a razor knife or a blade, and it's very simple to use. The reason this is a suitable material is, number one, it's very cheap and easily available. An entire sheet of corrugated plastic, which is enough to make two large aircrafts as big as this, just costs about 800 Indian rupees. So which means I couldn't make two aircrafts with this one because I didn't have an entire sheet for myself, but with whatever I had, I managed to make an aircraft with a wingspan of about 1.5 meters. The back, tail, and the vertical stabilizers and the tail wing, they're all attached to the fuselage using 743 or super glue. I've also used Fevistick. That's a very strong glue that is suitable for using for making RC aircrafts and different craft models that you want. And this wing, which is 1.5 meters in length, is attached to the fuselage using 2 or 3 rubber bands depending on the strength of each rubber band. Because these rubber bands are small, I've used only 2 of them, but if you're using much larger ones which aren't as tight and strong as this, I would suggest using 4 or sometimes even 6 of them. So the entire thing over here is explaining how these things fly. And as you know, aircrafts and drones and helicopters, all of them fly on a physics principle known as the Bernoulli's principle. To simplify this entire concept, here's what you need to know. Every aircraft, whether it's a helicopter or a drone or anything that flies, mainly airplanes, use a certain structure known as airfoils. Airfoils look like this. A certain cross section of the wing is what is known as an airfoil. Now, airfoils are structures which are designed in such a way that they divert the flow of air above and below the surface of the wing, which means that the flow of air above the wing and the flow of air below the wing is at different speeds. And different speeds of flow of any fluid basically causes something called a pressure difference. In the case of aircrafts and in anything that flies, the pressure difference is such that there is a higher pressure below the surface of the wing and a lower pressure above it. Now, this pressure difference basically pushes the wing up and it generates the force of lift, and that's how the entire thing works. Now, drones and helicopters work on a principle where thrust is generated below the aircraft itself so that it can push itself against the force of gravity and it can hover in the air. Aircrafts, on the other hand, use motors. This particular aircraft is supposed to use a 1000 kV BLDC or brushless direct current motor, which is supposed to generate enough amount of thrust to make this aircraft fly smoothly in the air. A 1000 kV motor basically means that for every volt of electricity supplied to the motor is going to rotate 1000 RPM. So a typical lithium polymer or a LiPo battery, which we are going to use to fly this aircraft, can supply about 11 to 12 volts of electricity to the motor, but it can rotate about 10,000 RPM at its full throttle, and that's because some other voltage will also be used for the other stuff like the servo motors and the rudder in the case of this aircraft. Also, had to mention, this aircraft doesn't have a rudder. That's because I designed it entirely by myself and I didn't need that extra stability. This is the first model that I built, but what most people do is they can also create a rudder on the tail, and you would need an additional servo motor to control the movement of that rudder, which means you're going to need another channel on your receiver. So I'll get to all those electronics in a different video, but coming back to the airfoil. The cross section of the airfoil looks like this, and the pressure difference creates the force of lift. Now let's talk about what helps the aircraft pitch up and pitch down, essentially increase and lose altitude. The components on the aircraft which help it increase and lose altitude are known as the elevators, and the elevators are located at the back of every aircraft. These elevators are connected through a metal rod to a servo motor which is mounted on the right hand side of the fuselage. The elevators basically move up and move down in order to direct the flow of air above and below the surface of the wing. So when the elevators move up, the flow of air is in such a way that it pushes the back of the plane down and the front of the plane pitches up, therefore the airplane gains altitude. In order to go down, the opposite happens. The elevators move downwards such that the air pushes the back of the plane up and the nose pitches down and the aircraft is going to lose altitude. Now the elevators only direct the pitch of the aircraft and do not direct direction. What actually controls the direction of the aircraft in which it flies is known as the ailerons. The ailerons are very important because this is what determines the direction in which the aircraft flies. It shows how stable the aircraft can take a right turn, how fast and stable it is when taking a left turn, and all of those factors. So the ailerons are basically split on two sides of the wing, and that's because they don't move in coordination with each other. They don't move in the same direction as the other. In order to turn right side, the right elevator is going to pitch up and the left one is going to pitch downwards. That is going to create a difference of pressure on both halves of the wing and the plane is going to tilt right, so it's going to fly right. The opposite happens when it has to turn left, so the left aileron turns upwards and the one on the right moves downwards, and that also creates a pressure difference and the aircraft rolls towards the left. The rudder, even though I don't have it, basically how it works is the back portion of the tail is split in such a way that it can move on the same x-axis right and left, such that the flow of the wing when the rudder is turned in any direction will direct the aircraft in a direction to change whether right or left on the x-axis itself. So the aircraft is not going to change its axis, it's not going to move on the y-axis or anything, it's just going to change its direction on the x-axis, on the same axis, without rolling right or rolling left. This is extremely useful during windy conditions, during landing and during takeoff, but otherwise there's really no use for these aircrafts. So that was it. That was a video just simply explaining how RC aircrafts like this and in general larger aircrafts fly. In the future, I will definitely come out with a video explaining all the electronics and of course demonstrating a flight of this aircraft, and hopefully that will be very, very soon. So thank you for watching this video, and if you liked it, please give a thumbs up and subscribe to this channel, and I'll see you guys in the next video.